Hello and welcome to this wonderful presentation with Dr. Pallavi Karanth. She is a research software engineer at TIB. Every time I attempt to spell out the acronym of TIB, I fall flat on my face. It's a German acronym for a research and science library in Germany, right?
Correct, you're right. Yeah. It's
Technique.
National Library for Science and Technology, although in German it is Technische Informationsbibliothek.
There you go. Well, it's a pleasure to have you, Pallavi, and we every time we talk, I learn something new. You've been a veteran of the symbolic AI space, the semantic technology space, for more than a decade. You've held contributions in marketing and medicine and all sorts of novel areas. I think most recently you've been working with a chemical manufacturing project. Um, I'm just amazed every time we talk that you have so much diverse knowledge in all these areas.
Hey, hi, Woken, and everybody online. Thank you so much, Woken, for this opportunity to be here today as part of Human Plus AI Symposium. And I thank you a lot. And the entire AI community is really grateful for you because you always come up with something new with diverse perspectives. You pick speakers so that they throw light on different aspects of AI, and it's always a cool thing with you and Swarm community. Thank you so much.
Thank you.
Yeah, yeah. Let's get started. And today I'm here very excited to talk about current trends and future frontiers in AI research. Um, Walken has already given a brief intro about me. Let me go into the research trends in the year 2024. Industry has continued to dominate frontier AI research. And in the year 2023, industry produced about 51 notable machine learning models, while academia contributed only 15. And there were about 21 notable models resulting from both industry and academia collaboration, which is again a new high. So now let's see some revealings from Epoch AI. Epoch AI is a research institute, and it investigates key trends and it answers questions which will shape the trajectory and governance of artificial intelligence. Epoch AI findings reveal that the large US companies like Google, Microsoft, all of them are rapidly scaling up their training compute. Specifically, Google's training compute grew approximately 10 million fold over 11 years, whereas OpenAI and Meta each expanded by around 1 million fold within the last 6 years. And this definitely exceeds the general trend in ML systems. And if we look at the last 10 years, the field of compute intensive training runs in AI has seen significant shifts. And initially, it was dominated by Google's AI labs. And later in 2015, OpenAI, even though it was founded in 2015, it quickly matched and even surpassed Google DeepMind's compute levels, especially with its GPT-4 model. And OpenAI's rapid progress has been facilitated by a partnership with Microsoft. We also have a new player, Anthropic, the model Cloud 2, which neared the compute scale of Google's Palm 2. And Meta, with its close, it has remained slightly behind the leaders. Industry always has had access to better models, and it basically has access to large economically valuable data sets. And the computing power, even in the computing power, we see a growing divide between industry and academia. And industry's ability to hire talent, harness greater computing power, it likely arises because of its difference in spending when compared to academia. We can also see the difference in the AI outcomes like publishing, be it creating largest AI models or beating key benchmarks. Um, And one more revealing is AI models always embrace open source. More and more foundational models have been developed, and around 65% of them are open source models. The domain of AI has experienced a significant transformation with the emergence of open source models. And these foundation models constitute large scale AI models. They are basically pre trained on vast amounts of general data, and they can be adapted for downstream applications. So basically, they have this strategy of pre train and adapt. And this approach, it has expedited the development of innovative AI products and services. So foundation models have shown their remarkable abilities in different domains. Take examples of software debugging or protein sequencing or creative generations, or with GPT-4o or the latest models, the cross-modality outputs, right? Even text-to-image creations. So with all of these, foundational models have shown really good capabilities, and it broadens the scope of applications achievable by a single model. We don't need to train specifically, and it would be trained on general data, but still it can be fine-tuned using effective prompt engineering techniques. It significantly will lower the costs when developing new applications in AI. So with this, right, we can have a vast range of applications across various domains in the industry using only very few foundational models. And open AI systems always foster collaboration, and they support innovation, and they support community contribution, with the disadvantages only being quality control and security risks. So whenever a business or industry has to choose between closed AI and open AI solutions, it always has to see whether the applications require transparency, whether innovation is a priority, or quality concern is a priority. So if innovation is a priority and transparency is crucial, which is crucial in the coming days, open AI is better. But in cases for domains like finance, where security is a major concern, closed AI is better. Now coming to the increasing training costs of AI models, right? The costs have gone reached unprecedented levels. OpenAI's GPT-4 used around 78 million worth of compute to train, whereas Google's Gemini, its cost is $191 million for training compute. Now going to some of the other research trends. So as we know, open source AI research explodes, and US is leading in the top AI models. US in the year 2023, it produced around 61 notable AI models originated from US based institutions, and it has far outpaced the European Union's 21 and China's 15. And even the number of AI patents, right? It has skyrocketed. More than 62% AI patent grants have been there in the last 2-3 years. And China has been leading global AI patent origins. So when you consider the number of GitHub projects, so we talked about open source AI, so the number of GitHub projects has seen a very sharp increase. If you consider from 2011 to 2024, it is more than 1.8 million GitHub projects, AI-related projects are there. So this is the current trend when it comes to AI. Now going into the space of generative AI. So it's already pervasive, and in the next 2 to 3 years, it will have most impact around content generation and discovery, conversational AI, and simulations. So Gartner has a few findings when it comes to generative AI, how it is going to be used. So there are already a lot of virtual assistants and conversational AI solutions. Industry and function specific intelligence will see a large impact coming from generative AI. and there will be a new era of customer and employee experience. So, Gen AI will transform enterprise content search, discovery, and the use of Gen AI in simulation software is already prevalent within the CRM space. And Gen AI is also used for engineering technology, material discovery, although there are still concerns about reliability and safety of human life. Gen AI also, Gartner suggests that by 2025, 80% of systems integrators will use Gen AI in their different phases of software development lifecycle. And more than 50% of the directors of large companies will start using generative AI for ideation, scenario planning, decision optimization. And we can also see that by 2030, most drug leads, the discovery of all new drug leads will come through some usage of generative AI. We know there are quite a few challenges about large language models. I think in the very first presentation, we saw how large language models can reason out. Do they have those capabilities? So, presenting false information when it does not have an answer, or presenting out of date information, creating a response from sources which are non authoritative. So, there are, of course, challenges within the large language model space, and hallucination is always a thing because it's just about probabilities. Retrieval augmented generation, that is the process of optimizing the output of a large language model so that it always references an authoritative knowledge base outside of the training data um, before it actually generates a response, in which case it would reduce hallucinations. Now going into the space of AI across different verticals, right? How AI is being used and what are the different advancements in various areas to see what is happening within science, right? Alpha Dev, an artificial intelligence system, it uses reinforcement learning. It has discovered enhanced computer science algorithms, and it has surpassed those which were discovered or honed by scientists and engineers. AlphaDev uncovered a very faster algorithm for sorting. AlphaDev basically is based on another tool, AlphaZero. So AlphaZero, it is also based on reinforcement learning model, and it had defeated world champions in various games like chess. And with AlphaDev, the team showed that the model can transfer from games to scientific challenges and from simulations to real world applications. AlphaDev usually observes the algorithm that it has generated and the information that is contained in the central processing unit. And AlphaDev basically tries to see what is the next best instruction to be added by looking at the assembly level instructions. So that is where it was able to discover a very fast algorithm for sorting. And AlphaDev has also been used in hashing, and it was found that it was 30% faster than the algorithms discovered by scientists. And another application of artificial intelligence within science is GraphCast. And with a high resolution forecast, it is able to predict 5 Earth surface variables and atmospheric variables at each grid point. And as of date, it claims to be the world's most accurate 10-day global weather forecasting system. So the importance of the model is caused by its accurate predictions, and it takes less than a minute on a single machine, and it has surpassed all the previous algorithms for weather forecasting. GraphCast's ability to identify even the severe weather events earlier, and that means that we would be able to be warned about different atmospheric events as well as cyclones, and which would definitely enhance preparedness, and it would reduce the impact of extreme weather. One more application within science is the 3D mesh. We have Flexi Cubes by NVIDIA. And 3D mesh generation, it is very crucial in different applications. So when it comes to computer graphics, it is key to video games, it is key to animation, and even within the space of healthcare, it is key to medical imaging and scientific visualization. So FlexiCubes is one algorithm which addresses the limitations of traditional surface extraction algorithms, and it is precise. It will allow for localized mesh adjustments, and in this way it is very useful in the space of medical imaging and physics simulations, which had not happened before. Now coming into the space of medicine and healthcare, so how AI has advanced and how it is helping human beings. There is a new artificial intelligence tool called Evescape, and it has been developed by researchers at Harvard and University of Oxford. Basically, Evescape takes two inputs. So there is a model of evolutionary sequences. It predicts the changes that can occur to a virus, and there is also detailed biological and structural information about the virus. So taking these two into account, Evescape can make predictions about the variants most likely to occur as the virus keeps evolving. So this basically, as the last pandemic unfolded, Marx and her team, they saw an opportunity to help out. So they built Evescape for the purpose of predicting viral variants. So this has been applied on SARS-CoV-2, COVID-2 in real time, and every once in 2 weeks, researchers publish the ranking of the new SARS-CoV-2 variants on their website, and this information is shared with entities such as World Health Organization. They're also using this to study different viruses like Nipah, Lassa. They are having pandemic potential, and the Evescape as a tool would definitely help and have a huge impact on human health across the globe. It also would help to evaluate vaccines and therapies, which means that the access to vaccines as the virus evolves would be much faster than before. And in the same space of healthcare, we have a tool called Alpha Missense. So researchers at DeepMind have presented this tool, Alpha Missense. And Alpha Missense basically is a tool where it focuses on the missense mutations. So there are genetic mutations, and it would predict which genetic mutations are pathogenic. So that is a breakthrough which could help researchers to know more about rare diseases. So usually it focuses and finds where there are missense mutations, which means that there is a single nucleotide change. There is a single letter of the DNA code is affected, and that is when it can change the resulting amino acid. So an individual usually has 9,000 of these mutations, and most of which are benign, but some of them which are pathogenic can cause diseases, rare diseases, including cancer, sickle cell anemia, and fibrosis. So AlphaSense as a tool was able to classify or categorize the different mutations. There are 71 million possible mutations, and it was successfully able to categorize 89% of them. And out of which it says 57% were benign and around 32% were pathogenic. In contrast, as human annotators have been able to confirm the nature of only 0.1% of all the missense mutations, which is definitely a real good advancement in the space of medicine and healthcare. So we have seen the different advancements in healthcare. It could also lead to already there are applications, robot assisted surgeries. There are virtual health assistants, and as we have seen, there can be better treatment of rare diseases, and there can be improved healthcare access. So all of these are advancements within the space of healthcare. And now coming into the space of manufacturing, right? So what's happening there? We have cobots. So cobots are collaborative robots. So they work in proximity with human employees, and they're definitely different from the traditional industrial robots, because they work in the same space as human workers, and they really need to be very safe. There are sensors. They will ensure that the robot never injures the co-workers, and they are being used for various applications, be it stationary or mobile applications. Um, they are used for assembly. They are used for material handling. They are used for quality control. They are also used for order picking. They are used for loading and unloading within the conveyor belts. They're used for workpiece transfers. So that is one advancement within the space of manufacturing. And then now we also have proactive maintenance. Proactive maintenance is one thing where AI is always used to monitor and analyze the data from machinery and shop floor processes. Manufacturers can immediately identify anomalous patterns, and they would be able to predict or even prevent breakdowns. AI can process vibration, it can do thermal imaging, it can do oil analysis, and it would be able to assess the health of machinery. So, which means that it is very easy to predict the downtime, and this will definitely have a big impact on production planning and all the related activities with the manufacturing. And generative AI can further add value. It can scan documents, it can scan maintenance logs, it can scan manuals, and it can provide precise information to the users to be able to troubleshoot in a better way. Um, and now coming into the challenges within the space of AI, which definitely would mean they are the future frontiers in AI research. So we know that AI and ML powered systems continue to proliferate, and it's quite natural to wonder how safe they are and how trustworthy they are. Their popularity is undeniable, but it leaves us to wonder if they are black boxes. We don't understand how they are able to deliver some results. So explainability was also covered in the previous talks. Explainability is one of the four ethical principles for trustworthy AI, along with other principles like human autonomy, the prevention of harm, and fairness. So explainable AI, as we all know, it is a set of processes. It will allow us to comprehend the results of AI and machine learning algorithms better. And when it comes to explainability, transparency is right there. Transparency is defined at different levels. So it can be either algorithmic transparency, it can be interactive transparency, or social transparency. So algorithmic transparency is one which is the most researched and well understood when compared to the other two. So when it comes to algorithmic transparency, there needs to be ability to access and scrutinize the code, the data sets, and all the accompanying systems in this space to be held accountable. And understanding the interaction between the algorithm and the data is the core when we look at algorithmic transparency. And interaction transparency is another important space which is not so much researched, but much research is needed in the future. It is basically a human and agent interaction problem, and therefore we require some kind of embodied interaction design, and that will play a key role in enabling transparency. Then there is also the social transparency. In Europe, especially, consumer and data protection, much emphasis has been already played on the information, and we already have the implemented solutions like cookie consent banners for transparency in data collection. And there are social challenges with regard to the transparency, and they require more consideration in the future for more safe and trustworthy AI systems. Now, when we consider challenges, some more challenges are there. So we know that awareness, right? For humans, we have evolved, and as Kurt Kegel recently posted, and he was talking about self-awareness and how the machines are different. We For us as humans, we have the capability of self reflection, and we have awareness of ourselves, whereas for the machines, they are not yet there. There are different levels of awareness. So if we say basic awareness, how can AI systems perceive the environment, right? They currently are able to do with some kind of predefined rules, as well as with learned patterns over a period of time. And there is perceptual awareness. So we have a lot of sensors with IoT, that is possible. There are sensors, they help machines to create some kind of understanding of the environment. And reflective awareness, so AI systems can analyze their own performance, and they are able to do adjustments based on the feedback. So there are reinforcement learning strategies. So based on the feedback, they are able to see what has happened and how it can get better over time. But when it comes to self-awareness, this kind of awareness, which it is quite natural for humans, it requires some kind of introspection, understanding, and having a concept of self. And currently, AI systems do not possess them. I would like to touch upon other two aspects: machine interoperability and actionability. Interoperability usually comes from using the same schema or interoperable schemas. So within the space of knowledge graphs, schema and semantic interoperability can be defined, and it is not yet accomplished fully. And even the machine actionability, right? Machine actionability aims at clear, explainable decision making capabilities for the machines. So we are somewhere in between immature symbolic and generative systems, and mature symbolic and generative systems. So there is more to accomplish in this space, and more challenges to be faced and dealt in the space of AI research. Yeah. This is what I had to share within the space of AI research. So what will the AI world with AI look like in the year 2030? So there are predictions that global GDP will be higher by 14%, and within the space of personalization, there would be more product variety, more personalized and customized. And within the space of automotives, predictive engine monitoring and maintenance would be possible. Within space of healthcare, there would be more faster diagnosis. And within finance, there would be personalized financial planning. So all in all, we would have definitely advanced in the space of sustainability, trustworthiness, and responsibility. So the AI systems would be more sustainable, trustworthy, and responsible. And there is an initiative called AI 2030, and this hosts events across the world, and there are people getting actively involved to see how AI systems will be more focused on sustainability, trustworthiness, so that uh, we would increase the positive outcomes of AI systems while reducing the negative outcomes of AI systems. Now, if in AI research you would like to know or know about more research, or find out what you're curious to know about, you can use this tool called ORKG Ask. And this tool is in-house to TIB, and it helps us to be able to skim through the knowledge graph which is open, and it is about many publications across different scientific disciplines. So Ask has a conversational interface. So this enables enthusiasts, curious people to know more what's happening within the space of research. Yeah, and this is all what I had to share, and I would be happy to take any questions.
Thank you very much for the presentation, Pallavi. You always come with such a expansive view of how things are shifting, and just laying the framework of where we stand. And yeah, like I said before when I introduced you, I'm always learning from you. um, we have one question: how can aspiring or early career researchers get into and contribute to the development of new standards and best practices in responsible AI? Thank you, Vibhat.
Yeah, a good question. So, first of all, when it comes to responsible AI, right? There are many aspects to it. So, a responsible AI system needs to be trustworthy, it needs to be fair, it needs to be safe, it needs to be ethical. So, I would say whatever is more interesting or curious in these different, you're curious to know about in these different aspects of AI, start researching by asking ORKG Ask. You can use this tool to find out what's currently happening, the current state of affairs, and then use your curiosity to get involved with different researchers in the AI space. And as I told, it is all more and more open source now, and there are GitHub projects available, and people are reachable on LinkedIn, and yeah, it's just that we just need to have the right spirit and just get hooked on to the space.
If anybody's listening that is pursuing a graduate or PhD program, you can also reach out to me and I can direct you to someone that helps to place early stage researchers into some are paid and some are unpaid research opportunities. So I'd be happy to make that connection for you as well. Ban Shah is also saying very insightful. Um, so, what are your thoughts on your current work? Where do you see that evolving? Right now, I think you mentioned you're developing a knowledge graph to support decision making in a manufacturing company based on what kind of inventory they have. Here's what kind of products you can produce. Um, how do you see that impacting industry?
Yeah, I mean, I work for a research project within the material science domain, and here, especially within Europe and especially in Germany, they are coming up with standards to be able to represent the domain knowledge um, in the right way. And when there are standards, semantic interoperability or machine interoperability becomes easier. So that is where we are heading it. We have started small, but definitely it will get big in the coming years. So once we have the domain knowledge being standardized, put into a machine understandable and interoperable format, um, it is just we are in just the start of the game. So once this happens, lot of avenues will open up, and there will be, it becomes easier for building AI applications which can do more and more, and in the most transparent and trustworthy space. So in the knowledge graph space, since we work on ontologies and we make knowledge explicit, explainable AI is something which is inherent to us. It is there well within the ontology space. And yeah, material science or chemical industry or many more industries will definitely benefit. And it is just in the start, and definitely the space will evolve very soon to be able to um, make autonomous systems being able to interact, be interoperable, and achieve more with AI.
And in your career, you've mentioned we've had a podcast that's going to come out in the near future, but would you share some advice for students that are entering into this space of artificial intelligence, particularly in symbolic AI? You have to have an open mind. Do you have any words of wisdom that you can share with the youngins, the freshers?
Yeah, I would be very happy to mentor if somebody is quite interested and curious to know on the symbolic AI space, knowledge graphs, semantics. Um, I would say come with an open mind, keep your curiosity alive, and that is when you can just be able to understand any domain and be able to do really well in representing the knowledge of the domain for building more and more robust, more trustworthy AI systems.
And with that, thank you guys for tuning in. We'll be taking a short break, and then we're gonna be right back with the next one. So, see you soon.
Thank you. Thanks, Woken, and thank you, everyone.